Here we are in section 2.4, exercises 1 through 6. We've got some word problems here. Remember, we're going to find the data, variables, our plan, thinking it through in order to be able to write an equation. That's how we take it out of the world of English, put it into the world of math where we know how to deal with stuff. This one tells us what our plan is on all 6 of these. We will be translating it. So let's do that, highlighting the data and the variables. Jeff's age, that's J, is 6 more than 3 times Amber's age. So J equals 6 more than 3 times Amber's age. Jeff is 27. So that tells us what J is. So we get 27 equals 6 plus 3A. Oh my goodness, look at what we have here. We've now, through translation and substitution of that 27, we now have an equation we know how to solve. Yeah, we can do it. How old is Amber? Find the A. That's the key. So subtract 6 from both sides. We get 21 equals 3A. Divide by 3, and A equals 7. So we get that Amber is 7 years old. Cool. It's like magic undoing all of that weird English stuff. All right, number 2. This year, Chris, that's going to be one of the variables, will be 17 years older than, that's a plus, twice Charlotte's age. So K and C. So let's write that equation out in math. K will be, that's the equal sign, 17 older than twice Charlotte's age. And it says if Chris will be 49, so let's put that 49 in where the K is and see if it gives us an equation. 49 equals 17 plus 2C, and it does indeed. We have an equation. Yay! Happy math land. Subtract 17 from both sides and we get 32 equals 2C. That means C is 16 years old. Put years in there. Great. Number 3. Rick's cell phone bill is, so the bill here is going to be, we'll put a B there, is $38 plus $2.50 per gigabyte. So this is $2.50 per gigabyte. So if the bill is used how many gigabytes? Let's use G for the variable. So this is going to be B is 38 plus 250 times the number of gigabytes. And then it says the bill was $70.50. Goes right there, $70.50. Has to equal 38 plus 2.5 G. Now, some would do it and say, well, let's take the 70/50 and subtract 38, and then we can divide by 250 and find out. And you'll see that's exactly what we're doing. Subtract 38, and we get 32/50 equals 2.5 G. Divide by 2.5, divide by 2.5, and we get that G equals 13. So 13 gigabytes. Excellent. Number 4. 18 less than 5 times the number of pennies. Okay, whoa, 18 less than, this is subtract, but remember the 18 goes here and the 5 goes there. 5 times the number of pennies. So there's our variable right there. P is the number of quarters. So there's a variable. Q, if there are 52 quarters, how many pennies are there? So let's write this down. 18 less than 5 times the number of pennies. So that's 5 times the number of pennies. Then go 18 less than that is the number of quarters. So where's is? That's the equal sign. And it says that if there are 52 quarters, so Q is 52, so we can take and put that guy right there. 5p minus 18 has to equal 52. How many pennies are there? Yep, let's solve for p. Add 18 to both sides, we get 5p equals 70. Divide by 5 and we get p is 14. So we get 14 pennies as the answer. Excellent. All right, the next one. Number 5, 3 consecutive odd integers add to 93. So this is going to be, there's going to be addition here equals 93. Now, consecutive, how do we do consecutive? Well, you pick a variable. So let's pick one of them to be x. The next odd integer, so like if this were 7, the next one would be 9, so it would be up by 2. Are we okay with that? If it were 11, you'd have to go up by 2 to get to 13. If it were 21, you'd have to go up by 2 to get to 23. And the next one, you'd have to go up 2 more, like that. So here are the three numbers, 1, 2, 3. So it says they add to 93. So it's x plus 2 plus x plus 4 equals 93. And we have an equation. We know how to do this. 3x plus 6 equals 93. Subtract 6, we get 3x equals 87. X equals 29. But notice, what are they? We need all three numbers. So if we stick this back in, 29 here, then this guy has to be 31, and that guy is 33. Excellent. Those are the three numbers. And look at that. We did it. Consecutive odd integers. If they were not odd, we would have just done x plus 1 and x plus 2. All right, the next one. Three consecutive even integers. Well, let's write those out. So we got x, and then the next one up, if this were 4, the next one up would be 6. We'd have to go 2 higher again. Notice that either to stay on the odds or to stay on the evens, we have to add 2 and add 4. Okay, so those are the three consecutive integers are such that the sum of the smaller two, so this is going to be x plus 2, is, that's an equal sign, 52 less than, remember that subtraction, but that guy goes over there, 52 less than 3 times, there's a 3, times the largest. So 3 times the largest, x plus 4. Well, let's read it one more time, make sure that's true. Three consecutive integers. So here's the smallest, medium, and largest of those three. The sum of the smaller two, that's the sum of these two, that's that right there, is, that's an equal sign, 52 less than, so that's 52 less than something, 3 times the largest. Excellent, excellent. Okay, what are they? So we got to find these. Look, we have an equation. We know how to do with that. Distribute that, and we get 2x plus 2 equals 3x plus 12 minus 52. Subtract, I don't know. Subtract 3x over here, and we get a negative x plus 2 equals 12 minus 52. That's a negative 40. And subtract 2 over, we get negative x equals a negative 42. So that means x is 42. So if x is 42, then the next one up is 44, next one up is 46. Ooh, that's crazy. Is this true? If you take that one plus that one, that's 86. Is that really 3 times that and then go down by 52? 3 times 46 is 138 minus 52 is 86. Oh my goodness, it works. Shazam!